Okay, 3.2 parallel lines and transversals. Now, before I move forward, it's really important that you understand the previous notes from 3.1. So we learned about some special angle pairs. And those special angle pairs were on that back page. Corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. If you still don't have these memorized, you need to learn these. Otherwise, this next lesson is not going to make any sense to you. Okay, with that in mind, here's our essential question. When two parallel lines are cut by a transversal, so now the change that we're doing from the last lesson is now we're talking about what happens when my two lines that are cut by the transversal are actually parallel. Which of the angle pairs are going to be congruent and which are going to be supplementary? Okay, so you're going to have some of those angle pairs, these angle pairs from our previous lesson. Some will be congruent and some will be supplementary. And that's what we're going to talk about today. Okay, so we're going to go through the parallel lines theorems. And in order to do that, I've kind of taken this diagram and we're just going to go through each and every single one and use the exact same diagram. And lines L and M in these diagrams are going to be parallel. T is our transversal. Okay, so the first one is the corresponding angles. So if I have two parallel lines cut by a transversal, then the pairs of corresponding angles are going to be congruent. Okay, so corresponding angles, when I have two parallel lines, so these are parallel lines theorems, they only apply to parallel lines being cut by transversals. Okay, anytime that I have corresponding angles formed by that, then the corresponding angles will be congruent. So that kind of blurred it. So if we know that the measure of angle 1 is 105 degrees, this angle right here is 105 degrees, then what else do we know? Well, what's a corresponding angle with angle 1? Well, corresponding means that they're on the same side of the transversal, so it'd have to be on the left side of the transversal, and this is above its line that's being cut by the transversal. So angle 5 is also above, it's in the same position, right? So angle 1 and angle 5 will be congruent, so we also know then that the measure of angle 5 is equal to 105 degrees. I'm going to stop there. I mean, from there we can figure out what every single one of these angles are, but we're not going to do that right now. Okay. Next one. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles, so alternate interior angles means that they're both on the inside of their lines, and they're alternate sides of the transversal, so like 4 and 5, and 3 and 6. So the pairs of alternate interior angles are also going to be congruent. So again, these are all parallel lines being cut by transversal, so alternate interior angles will also be congruent. So if I know that the measure of angle 6 is 72 degrees, what else do I know? Well, what's the alternate interior angle with angle 6? It's angle 3. So we know that that's also going to be 72 degrees. I don't know why these don't have 72. I don't know why they don't have degree symbols, but whatever. Okay, next one. If two parallel lines are cut by a transversal, then the pairs of alternate exterior angles. So alternate exterior means that they're on the outside of their lines. Right, so they're on the exterior of the lines, and they're on alternate sides of the transversal. So angle 1 and angle 7 are alternate exterior. Angle 2 and angle 8 are also alternate exterior. And these are also going to be congruent. So alternate exterior angles will also be congruent. So if I know that the measure of angle 1 is 110 degrees, well, the alternate exterior angle to that is angle 7, and so I also know that angle 7 is going to be 110 degrees. Okay. Last one. So hopefully you're finding this to be quite simple. If two parallel lines are cut by a transversal, then the pairs of consecutive interior angles. Okay, consecutive interior angles are going to be right next to each other on the inside. So they're on the same side of the transversal, and they're on the inside of their respective lines, and they're right next to. Consecutive means one right after the other. Okay, so they're right next to each other. So like 3 and 5 are consecutive interior angles, and so are 4 and 6. Well, these are not going to be congruent. I mean, just look at these. They don't, right? One's obtuse, the other one's acute. These are going to be supplementary. And this becomes really important when we start dealing with polygons. You're going to realize that some of these parallel lines in the side basically mimic what's happening here. And so we're going to be able to figure out different angles in polygons. Okay, so angle 3 and angle 5, those are not congruent. They are supplementary. So if I know that the measure of angle 3 is 80 degrees, well, angle 5 is not also going to be 80 degrees. Okay, it's going to be something else. Well, together, supplementary means that they add up to 180. So the measure of angle 5 then has to be 100 degrees. Oops, putting the degree symbol in the wrong place. Okay, and I'm going to highlight that. So consecutive interior angles are supplementary. Great. So that's it. I mean, as long as you already know what these angles look like and the special angle pairs, now all you need to know is that 3 of them are congruent, and one of them, probably the hardest one to identify, is supplementary. Consecutive, a lot of people don't know that word, so that's why I'm saying that that might be hard for you to identify or to remember this name. All right, moving on. Let's do some examples then. Example 1, identify angles. So the measures of 3 of the numbered angles are 75 degrees. Okay, so one of them is already given to us. Identify the angles and explain your reasoning. Why do we know that they are what we are saying that they are? Is basically what we're trying to figure out. Okay, so first of all, this angle here is congruent with angle 7. How do I know that? They're corresponding angles, right? They're in the exact same position. They're both on the bottom of their respective parallel line, and they're both on the left-hand side of the transversal. So I know, and now that I've got 2 parallel lines, and I know that these are parallel because of those little arrows, then I know that these corresponding angles are going to be congruent. So the measure of angle 7 will be 75 degrees. And I'm just going to say, because of corresponding angles, corresponding angles. Okay, moving. Well, should I use the parallel lines theorem? I'm just going to say, how about in the very beginning, I'll say line P is parallel to line Q. And therefore, we'll know the rest of these things to be true. Okay, so I don't have to say like, due to the parallel lines theorem. Is that what it's called? Yep. Okay, moving on. Notice I don't memorize the names of the theorems, I just know the theorems. Okay, that's kind of important because we don't need to memorize a bunch of stuff that's not going to be helpful. We need to understand what it is that we're trying to memorize anyways. Hopefully that made sense. All right, moving on. So what else do I know? Well, what about, remember what we learned? Oh, let's go back to this angle 75 degrees is also related to angle 6, right? These right here are what kind of angles? That's right, they're alternate interior angles. Okay, so we know that the measure of angle 6 is also going to be 75 degrees because these are alternate interior angles. I'm using a little angle symbol so I don't have to write out angles. All right. What else do I know? Well, I also know that 75 degrees and this angle 2 are also related to each other. How are those two related to each other? And that didn't come from last lesson. That came from last chapter. That's right. These two are vertical angles, right? So I also know that the measure of angle 2 is equal to 75 degrees because it's a vertical angle. Now that has nothing to do with these two lines being parallel. It's just a vertical angle. Okay, and one more time, just as a reminder, we know that these lines are parallel because of these little arrows right there. Okay? And because these two lines are parallel, cut by a transversal, corresponding angles are congruent, alternate interior angles are congruent. Vertical angles are always congruent. Doesn't matter if you have parallel lines or not. All right, moving on to example 2, using properties of parallel lines. So we're going to find the value of x. Okay, let's see what I've been given. Again, I've been given that I have two parallel lines cut by a transversal. So special angle pairs are going to be congruent. Okay, so for example, this 2x is alternate interior angles with that angle, right? Well, how can I figure out what this angle is? This angle, how about I call this angle 1? Maybe that might be confusing. How about I call that, let's call that, what can I do? Let's call that y. Well, what do I know about 120 degrees and y? What do they form? Well, 120 degrees and this angle y, they form a linear pair. So together, they add up to, that's right, 180, right? So I know that 120 degrees plus, and I'm not going to use the degree symbol right here because we might think it's a 0, plus y equals 180. Okay, so then I'm going to solve for y. You might be able to do this in your head. So I know that y is 60 degrees. So this angle right here is 60 degrees. Well, then so is 2x. So I also then know that 2x is equal to 60 degrees. And now I can set up an equation, or I have set up an equation that allows me to solve for x. So I'll divide both sides by 2. We get x equals 30. It just said to find the value of x. I think I found it. All right, awesome. And I could probably do that problem a bunch of different ways. So I could have said, well, 120 goes here, and these two together are consecutive interior, and they add up to 180. Could have done it that way. I could have said, oh, well, how about 120's corresponding angles with right there? Those two would add up to 180. Could have done, I mean, we can use all those different angle pairs to set up several different ways of solving this problem. And all of them are correct. All right. Next, we're going to find the value of y. Well, again, I've got these parallel lines cut by a transversal. So my special angle pair, some of them are congruent and some of them are supplementary. This special angle pair, which one do we have here? That's right. These are alternate exterior angles. And alternate exterior angles are congruent. So I can set up a quick equation that says, well, 6y minus 3 equals 129 degrees. And then I'll just go ahead and I'll solve. So 6y equals 132. Divide both sides by 6. Y is going to go into 22 times. And I solved for y. Okay, moving on. Example 5. Notice I skipped example 4. That means that you're not going to be responsible for anything that looks like example 4. All right, example 5. A balloonist sees a car at a 37-degree angle of depression from horizontal. So you've got somebody in a hot air balloon here, right? The angle, this horizontal line, the angle of depression is angle 1, okay? So angle 1 here is what we would call an angle of depression, because if I'm looking straight out, then this is an angle that's going down, right? My viewpoint here, if I look down this way, right, is depressed from this horizontal line. Whereas like this car here, this car, its angle looking up is called an angle of elevation. And we'll talk about that a million more times. So it's not a sad angle, it's just an angle of depression because he's looking down. Okay, In the diagram, the measure of angle 1 is 37 degrees. What's the measure of angle 2? Well, notice this is a horizontal line, and so is this. All horizontal lines are parallel. So you can think of this line of sight from the balloon down to the car. You can think of that as the transversal. Making these two angles here, what kind of special pair? That's right, they're alternate interior angles. Okay, so we know that they are congruent. So the measure of angle 2 is also going to be 37 degrees. And we know this because these are alternate interior angles. Okay. Let's see. Let's do a couple of these. So, how about I'll do 2? Yeah, I'll do 2 and 4. Okay, so let's see. So there are no directions here except for here. So number 2, we're going to find x. All right, so M is parallel to N, so I know that these two lines are parallel. So these two angles, what kind of special angle pair do we have here? That's right, they're alternate interior angles. And if I have two parallel lines cut by a transversal, alternate interior angles are going to be congruent. So I can set up an equation that basically sets these equal to each other. And then I can solve. So I'll add x to both sides. So I get 3x minus 10 equals 65. And then I'll add 10 to both sides. We get 3x equals 75. And we'll divide both sides by 3. So we get x equals 25. It just said to find x, so I'm done. All right, and then moving on to number 4. Again, M is parallel to N, making these a special angle pair. What special angle pair do we have here? That's right, they're consecutive interior angles. So how do they relate to one another? Well, consecutive interior angles are always going to be supplementary. So these two angles, if I add them together, will give me 180. I wrote 10 and said 10 at the same time. Will give me 180 degrees. Okay, so now I'll combine like terms. Let's do 3 there. So 3x and 5x is 8x. Negative 10 and positive 30 is positive 20. Going through and solving for x, 160 degrees. Divide both sides by 8. X equals 20. And just said to find x. Cool. I'll let you guys go ahead and try 1 and 3.